On January 23, 2024, at 2:09 a.m. local time, a major magnitude 7.0 earthquake struck beneath the Tian Shan Mountains in northwestern China. As the ground shook, items fell off shelves, tiles fell off roofs, and some buildings even partially or fully collapsed. There were even some structures that experienced shaking equivalent to 60% the force of gravity, translating on an MMI scale to a reading of 8.5. This quake ticked all the boxes for what very well should have been a large-scale disaster. It occurred at night when the maximum number of people were in their homes sleeping, it occurred at shallow depths, it occurred in a region where structures are not very earthquake resistant, there was a large-scale nearby population which experienced heavy shaking, and regional cities were built in an alluvial plain. Expecting complete devastation, an early U.S. Geological Survey model predicted that at least $5 billion in damage occurred, with a 19% chance of this figure exceeding $10 billion. Yet the damage was surprisingly light. Instead of what I fully expected to be 5,000 collapsed structures, the actual total was only 50. A further 100 homes received some form of notable damage. As a result, the death toll is currently only 3. So, why exactly was the damage unexpectedly light? I want to first discuss the elephant in the room and note that this is not Chinese state media acting like Chinese state media and downplaying anything that might give the country a negative light. I checked from satellite to confirm that damage was indeed light, and there is actually a good scientific explanation for this. The reason is known as building resonance. Due to a number of variables, an earthquake can create oscillations in low, medium, or high frequencies, with each corresponding to causing the most significant damage in a structure of a specific height. Skyscrapers experience the most severe damage as a result of low-frequency oscillations, medium-height structures experience the worst damage as a result of medium-frequency oscillations, and short single-story structures experience the most extreme damage as a result of high-frequency oscillations. This means that a 1-story apartment building and a 10-story apartment building constructed right next to each other with the same building standards are likely to experience very different degrees of damage based solely on their height. In the case of what is now being referred to as the 2024 Ukturpan earthquake, the region seems to be filled with either single-story homes or 20-meter-high apartment buildings. Thus, we can infer that the magnitude 7.0 earthquake probably produced primarily low-frequency oscillations which caused overall light damage given the setting and magnitude of the event. However, if the same earthquake had instead occurred in a Chinese city filled with skyscrapers such as Shanghai, a death toll of 3 might have instead become a total of 30,000. However, there is an additional reason the damage was fairly light. The earthquake which occurred only shook the ground for 22 seconds, meaning it was unusually brief given its high magnitude. I looked at the duration of the last 10 magnitude 7.0 and 7.1 earthquakes around the planet, and the Chinese earthquake ranked in the bottom 10% in terms of duration. The earthquake which occurred could best be described as an oblique thrust earthquake with a left lateral strike slip component to it. The adjacent peaks are known as the Tian Shan Mountains, which represent a grouping of highly folded mountains in what is known as a fold-and thrust belt. It's quite easy to make out the northeast trend rock units have from satellite, and this represents the direction of every major nearby fault line. Stresses caused from the collision of the Indian plate with the Eurasian plate to the south cause large magnitude earthquakes in the vicinity such as what just occurred. As a final note, I want to caution that the many aftershocks likely to occur as a result of this large magnitude event could involve some events more damaging than the main quake itself, as these could create oscillations that shorter structures are more susceptible to. This is still a disaster and a tragedy, although not as devastating as was initially expected.